All right. When you think of periodic functions, what does that mean? How'd you describe a function that is periodic? Like, let's say x squared. Is this periodic?
It's not.
No, periodic means at a certain time interval, it is going to loop. It's going to restart. So x squared is not periodic, but trig functions are periodic.
So is it something that repeats?
Yep, it has to repeat and it has to be the exact same repetition. You cannot have you cannot have something like this in the beginning and then you have like this and then like that and then like something else maybe and then like that. The loop has to be exactly the same, okay? Like something like this. But you can get some more complicated things like this, like as long as the loop is exact, then yeah, that's fine. This is fine. You've seen like the heart rate monitor
Mm-hmm.
on TV shows and whatnot, right? Yeah, so that would be an example of a periodic function application. So let's look at this graph here. So on the x-axis we have time, and on the y-axis we have the height of some metal strip. What do you think the domain and range is of this function? Domain means what it can be on the, you know what domain and range is. You can
Mm-hmm.
use any notation. What would be the domain? The possible x values this function can take. Can it be negative?
No.
No, we're talking about time, right? What's the minimum value of time?
0.
0 is right. So on the domain, let's say we're representing the x values by x. So it's gonna be x is greater than equal to 0. Can be any time, can be any number as long as it's positive. What about the range?
It can't be over 9.
So y is less than 9? Like that? Does it have a lower bound?
It can't be under 1.
Right, so it's bounded between 1 and 9 like that. If you want the interval notation, it's gonna be like this. If you want the interval notation here, it's gonna be 0, infinity. Cool?
Mm-hmm.
So let's go back to this same question. What do they want us to actually find? Okay, now a periodic function has certain characteristics. The distance from one loop to another is called the period. Period is how long does it take for it to loop? How long does it take for it to complete one cycle? Cycle just means like a loop. To find the period, you can look at the distance between the maximum to the maximum, this distance here. You can look at the distance from the minimum to the minimum, right? These are good reference points. Or you can just pick any value, a y value, and see how long it takes for it to come back there. So something like that would also be the period. But this one's not a very good example because we don't know what the x value is there. So we're going to stick with either the minimum or the maximum. What's the distance from one minimum to another minimum?
It's 0.25.
Right, so the period is 0.25 seconds. Or 0.25. Remember how quadratic functions had a axis of symmetry in the middle that cuts it in half?
Mm-hmm.
This is called axis of symmetry. Cuts it in half vertically. Now, periodic functions have something similar. It's called the equation of axis. And instead of cutting it in half vertically, it cuts it in half horizontally. Now, how do we find that line? It's going to be invisible. So to find that equation of axis, what you do is you find the midpoint. It's always going to be at the midpoint. And midpoint is going to be the maximum plus the minimum divided by 2. What's our maximum here?
9,
What's our minimum?
1.
So divided by 2, your midpoint is at 5, okay? Therefore, your equation of axis, it's going to be a horizontal line, and we know horizontal lines are represented by y equals 5. So right here, this line right here cuts the graph in half, but horizontally. This is called the equation of axis. Cool.
Mm-hmm.
Next, these things have something called an amplitude, which is denoted by A, amplitude. An amplitude is the distance from the midpoint from the equation of axis line to either the maximum or the minimum. It doesn't matter which way you go. So what's the distance? And now we're talking about this in terms of y values. What's the distance from here to here? Or from here to here? They'll both be the same.
It's 5.
So 5 to 9, right? It'll be
Oh,
4.
it's 4.
It's 4. So you can either look at it up, down, or towards the maximum. It's gonna be 9 minus 5, 4. Or you can look at the minimum. It'll be 5 minus 1, 4. So that's the amplitude. What else is important here? Let's say that's it for this question, unless they want us to find something else. No, that's it. So those are some properties of a periodic function. Period is the time or the interval that it takes for it to loop back. Amplitude is the distance from the midpoint to the top or bottom graph. And the midpoint is simply max plus min divided by 2. Look at graph A, the one that says daylight hours. Is that periodic?
It is.
It is, right? It loops back to where it started. So what is the period? Period is the distance between any 2 points on different cycles. You could go from here to here, maximum to maximum. You could go from here to here, minimum to minimum. Or, because we don't know, I don't want to find out how much each box represents. You don't have to go from max or mins. You can go from any point as long as you get to the new cycle where it repeats. So I am gonna go from here to here. You see that point 12? It loops right
Mm-hmm.
back and the new cycle starts. So what is the period here? What's the distance?
365.
Yeah, so the period is 365. So we're gonna say period is 365. What is the maximum?
It's 18.
18 is maximum. The minimum is 6. You divide that by 2, add them and divide by 2. That will give you the midpoint. That'll be 12. So this line right here is going to be your equation of axis. What's the equation of that dotted line?
Y equals 12.
Y equals 12 is right. So what's the distance from 12 to 18? That's going to be your amplitude. That is 6, right? So your amplitude is 6, and you are done with that. Easy. What about B? Is B periodic?
It is.
It is. What's a period?
6.
6 is right. Your maximum is 1, and your minimum is -6. So what's the midpoint?
-2.5.
-2.5 is right. So -2.5 is between -2 and -3 right here. -2.5, and that's going to be your axis, which means your amplitude will be 3.5. Okay? The distance from here to here is 3.5. So that's a piston motion versus time graph. The height of a piston over time. This one is the daylight hours. So over here, are we looking at summer months or winter months?
Summer.
Right. And over here, we're looking at winter months. That makes sense, right? In the winter, you have less daylight. Periodic. What about C? Is that periodic?
No,
No, it's not. Why not?
it changes.
It changes, right? What could this be an example of? Over time, it's getting bigger and bigger and bigger, right? I mean, it says right there, question C, what this represents. It's you're swinging a meter stick up and down. And initially, you're not going to get much movement, but the faster you swing, the more movement you're going to get. Here's a real life example of this motion and sometimes why it's dangerous. This is a real life story. I don't know the exact names, but there's a bridge, okay? That connects point A to point B. It's a bridge. And even though it's a solid object, under high winds, it's gonna move. Same thing with buildings. Tall buildings, over high wind, if there's a high wind, it's going to move back and forth. It's going to sway, okay? This way and this way. Same thing with the bridge. Bridge is gonna swing left to right or up and down. You can go multiple ways. Buildings only go left to right. Bridges go left to right as well. It's hard to go up and down. And initially, the sway is not going to be that much. It's going to start with small movements, and then now it has gained some momentum for both of these, and it's going to get more chaotic. It's higher movements. And there you go, that's the graph. Here, this is your equilibrium point, this is your initial point, and over time, this is your sway. So you're moving to the left, you're moving to the right, and it's going to grow and grow and grow. And this has a potential to collapse bridges, and this has happened in Canada. What's the name of this suspension bridge? I'm trying to find a nice picture. Yeah, something like this right here. And this is what it leads to, okay? Because it sways back
Mm-hmm.
and forth. And now we have means to model this way, which means we can add things to reduce the sway. The opposite of this movement, this chaotic movement, is something called dampening. It's the opposite. So it starts off with huge movements in the beginning. Then over time, it gets smaller and smaller and smaller. In tall buildings, and if you've seen this, sometimes they have like this giant metal ball. Have you seen something like this? A lot of big towers have this. Here, let me show you a picture. Something like this. It's literally a ball inside of building. Okay, it's very heavy.
What's it for?
It's to prevent the building from swaying back and forth. It's to induce this dampening movement in the building. So when high wind does this, okay, to the movement of the building, the huge ball will counter that movement. It'll swing in the opposite direction, basically. So if the wind is pushing you this way, the ball is gonna go this way. So it kind of cancels out the movement and it prevents it from swaying back and forth.
Mm-hmm.
So that's the idea. Okay, that's why we're learning these things, because it does have real life implications, right? Like almost everything you've learned in any subject has real life implications. But it's kind of hard to put this in motion for, especially when you're looking at numbers and whatnot. But that's how you do it. So now you've seen the pattern. I mean, it's very simple. A is periodic. A, B, E, and F are periodic. That circle is definitely not periodic. And for C, that quadratic looking thing is also not periodic. It's easy as that. There's no movement. There's no pattern. Let's do this one. Is this periodic?
It is.
Right, it doesn't have to be curves. It can be anything as long as it loops back. It can be like this. It cannot be something super complicated though. Like I'm thinking about something like this and then it like repeats. But that is not a function, okay?
Mm-hmm.
This thing is not a function because it has multiple. It's gonna fail the vertical line test. A function is something that, you know what a vertical line test is? It cannot pass through multiple y values for the same x value. Like here, if you draw vertical lines, they're all gonna pass to one point. But if you have something like a circle is not a function. It's gonna pass through 2 points. This is not a function, even though it has an equation. What's the equation of a circle? X squared plus y squared equals r squared, where r is the radius. That's the equation of a circle. Okay, anyways, let's go back to this question. So this is periodic easy. Part B, at what depth does the pump turn on? Okay, so what are they asking us? When the pump turns on, what's the time?
0,
0. So what's the depth at 0?
4.
4, that's it. It's just asking for the y-intercept. So 4 centimeters is the answer to that. How long does the pump remain on?
For 6 minutes.
So the depth, it says decreased when the pump was on and increased when the pump was off.
So it stops every 6 minutes.
That's right. Okay, what's the period of the function?
8.
8 is right. What is the range of the function? Range means possible y values.
Y is between 10 and 4.
4 and 10. What will be the depth of the water at 3 minutes? So
6.
at 3 minutes, let's see. So minute is down here. You go up here, it's going to be 7. 7 centimeters. What will be the depth of the water at 10 centimeters? Or when will
You
it be
draw a
10?
line again.
Draw a line again right there. 6 minutes. Now here's the trickiest question. What will be the depth of the water at 62 minutes? Now you gotta use the properties of it being periodic. So your period is 8, right?
Mm-hmm.
So 62 means how many periods have you finished? You've finished 7 periods, okay? Because that's gonna be what, 56 minutes? You've finished 7 full periods, 7 full cycles, so 56 minutes have passed. So that means you're on the 8th cycle or the 8th period, and you're 6 minutes into that 8th cycle. So basically, if you keep drawing this pattern, you'll have finished 7 full patterns, okay, or 7 full cycles. And when the 7th cycle is finished, 56 minutes has passed. Now you're on a new cycle. And in this new cycle, 6 minutes has passed, okay? So in this new cycle, 6 minutes has passed. So this will be 62. The distance from here to here will be 6. So what's the depth at 6 minutes?
It's 9.
It's
Or
9 or
10.
10? 10, exactly. So it'll be 10 centimeters. Cool.
Mm-hmm.
So this is using the properties of the thing being periodic. So someone's riding a Ferris wheel and we're given the height and the time. Pretty simple graph. What is the period of the function?
8.
8 is right. So 8 seconds. That seems like a quick Ferris wheel, right?
Mm-hmm.
You're finishing like a loop in 8 seconds. I think that was supposed to be minutes, but whatever. What is the equation of axis? Equation of axis is basically the midpoint. What's the midpoint
Is
between
it
max?
force?
and min. It is 4, yeah. Because 7 plus 1 divided by 2. So your equation of axis is y equals 4. Then what's the amplitude?
Three.
3 is right. What is the range of the function?
Y is between 1 and 7.
That is correct. After 24 seconds, when will Trevor be at the lowest height again? No? So at what time is he at the lowest point? The lowest means the minimum. So he started out at the lowest point, right? After 8 seconds, he's come back to the lowest point. After 8 more seconds, he's come back to the lowest point. This point right here is 24. You see the pattern here?
8 seconds.
8 seconds, right? So what's the next one after 24?
8 seconds.
8 more seconds, so it's going to be 32 seconds. After 24 seconds, at 32, like this right here, is going to be the answer to E, 32 seconds. At what times is Trevor at the top of the wheel?
Four, 12, and 20.
So what's the pattern? What's the next one after 20? So after 20, when will he be at the top?
28.
28 is right. So here's how you can denote that. 4 is the starting time when he's at a maximum, yeah? Plus, after this, every 8 seconds, he's gonna be at the top. So 4 plus 8x, where x represents the cycle, okay? Or the new loop. And x can only be counting numbers or like whole numbers. It cannot be decimals, basically. It can strictly be integers only. Let's look at the next one. When will his height be 4 meters between 24 and 30 seconds? Just look at the pattern for 4-meter height. So we're just tracing this line. What's the time here?
26.
26. So 22, right? 18 plus 8 is 26. Yeah, that's right. Is there another number there? What about this? So the distance from 18 to this one, 26, is 8, right? So that's one of the answers. What about from here to here? Where the distance is also 8. What is this number?
Is it 8 or is the distance smaller?
It's 28. The distance is always going to be the period, so 28. Just add one full loop to this. You'll end up here. And the time there is 22 plus 8, so
Mm-hmm.
30. That's bad math. It's 30, not 28. And you're done, okay? So just periodic things. Just add the period. You'll get back to wherever you started off with.
Okay.
Now we've looked at periodic functions. The next type of function is a sinusoidal function. Sinusoidal just means a trig function, okay? But the difference between sinusoidal and periodic is sinusoidal functions are going to be smooth lines, like this graph over here. What I mean by that is, in example 1, A is the only sinusoidal functions, even though A, B, and D are periodic. B and D are periodic, but they are not sinusoidal, okay?
Mm-hmm.
It is not a sinusoidal function. Sinusoidal has to be like nice curves. You don't have like this up and down pattern, or it can't be like pointy ends. Let's try it in this one. So you're starting here at the point 3, 0, and you've rotated 70 degrees this way. Now the question is, what's this new coordinate? And you have to think about this in terms of SOHCAHTOA. Look at that triangle. Do we know any dimensions of that triangle? We know one side length of that triangle. It has something to do with the 3, 0. It has something to do with this line here. What does this line represent in a circle?
The radius?
Right, if that's the radius, what's the length of this line?
It's the same.
It's the same, right? It's still the radius, so that there is 3. Now, to find the coordinates of that, you're gonna need the x value here, which is the adjacent. And you're gonna need the y value up here, which is the opposite. So look at this. So sine of 70 is going to be the opposite divided by the hypotenuse, right? So sine of 70 is going to be opposite. We don't know what that is, but we do know the hypotenuse is 3. So right now we're in degrees. So sine 70 times 3 should do it. So sine of 70 in degrees times 3. So that distance, the opposite, is 2.82. How can we find the adjacent? There's 2 ways to do this. We know now that this side length is 2.82. Which means the y value up here, because this is the height of the triangle, is going to be 2.82. Now we need the x value of this triangle. We're trying to find A. Which one uses A and H, basically, or, yeah. Out of these
Which
three,
one?
cosine, right? So let's just do the same thing with cosine. Cosine 70 is going to be the a value divided by the hypotenuse of 3. So that means the a value will simply be cosine 70 times 3, and you're done. And these are not going to be exact values. So the x value there is 1.03, and you're done. It's just a SOHCAHTOA question. You can find side lengths. You can find side lengths if you have two else. L just means the lengths. So basically, opposite, adjacent, hypotenuse. If you have any two of them, you can find the third length of the triangle, or you have one length, but you have one angle. That's not the 90-degree angle. That's always going to be 90-degree, this thing. But if you have one length and one angle, you can find everything. Okay.
Mhm.
So here we had one length, the radius or the hypotenuse of the triangle. We had one angle, 70 degrees, but we could find everything else. If you don't have the angle, you're gonna need two side lengths. And you can do inverse to find the angle if you have two side lengths. Okay, most of these are just like period questions. Let's look at this function. So they got the graph from a graphing calculator. We could have gotten it from Desmos, but it's whatever here. All right. So what is the question? We're given a graph. The equation of that graph is up here. It says, how long is the employment cycle? So what are they asking us here? How long is the employment cycle?
They're asking for the period.
Okay, what's the period? Approximately.
It's 6.
Yeah, I would say it's 6. What is the minimum number of applications, approximately?
Two.
Yeah. Calculate J10. So let's say that value up there is 2. What does it represent? What does it mean in the context of this question? So after 10 years, right? Because we're tracking job applications or whatever. After 10
Mhm.
years, there's going to be 200 job applications per week, and that's it. Approximately 200 job applications after 10 years, because it's in the hundreds, and our Y value is 2. Okay, so Olivia was swinging back and forth in a motion detector, and this is the graph that's given. All right, what is the equation of axis, and what does it represent? So find the
The
equation.
equation of axis is 8.
It is 8. What does it represent? So let's say there's a motion detector here, okay? Olivia is here. She's swinging back, so she's going away from the motion detector, and the distance then will be 14. And then she's swinging towards the motion detector, and the distance from the motion detector to this point will be 2. So let's say this is, she swings back, that distance there is 14 meters.
So 8 is when she's not swinging.
Right, 8 is going to be her equilibrium point, okay, when she's not swinging. What is the amplitude of this function? Now that's pretty simple. We know this is 8. So what's the amplitude?
6.
6 is right, yes. What is the period of this function?
Four.
4 is right. What does it represent in this situation?
Her swinging back and forth.
You're right. The time it takes her to complete one full swing, right? So if she's starting at the maximum, fourth, so back, and then she's gonna go all the way to fourth, and then she's gonna come all the way back. So that's what it represents, one full cycle. How close did Olivia get to the motion detector?
Mm-hmm. 14 meters.
So that's how far she got, not how close. So what's the minimum distance between her and the motion detector is what's they're asking.
2.
2, yeah. So she got 2 meters, up to 2 meters. At t equals 7 seconds, would it be safe to run between Olivia and the motion detector? Explain your reasoning. Okay, I don't know what that means, but let's figure it out. So t equals 7 seconds. So we're here, yeah?
Mm-hmm.
So what's the y value there?
14.
14. So can we run between her and the motion detector? Or are we gonna collide with her? Which one is more likely?
Well, she's all the way in the back, so you probably can't.
Yeah, you probably can, right? Go for it. Make a run for it. So that'll be the answer to E. F, if the motion detector was activated as soon as Olivia started to swing from at rest, how would the graph change? So we know the motion detector detects up to 14 meters away, yeah?
Mm-hmm.
So what's going to happen here is that the graph is going to look, instead of starting at the equilibrium point, it's going to start at its maximum point like this. Not much changes. This thing just gets canceled out. You can draw your new axis from like right here. And that's what the graph would look. No, actually I'm still there. This right here, maximum distance away. That's what the graph would look like. You can ignore this bit. And that's it for that question. So we have two sinusoidal functions here. We have A and B. What are they asking us? Refer to the radius of each wheel and the height of the axle, the time taken to complete one revolution, and the speed of each wheel. Cool. Let's look at the red one. Paddle wheeler A. What is the period? I'll give you a hint. From here to here is one cycle. Okay. From here to here is one cycle. So how many cycles did we do in 24 seconds?
2.
2. So how long does it take to do each cycle?
12 seconds.
12 seconds. So for A, the period will be 12. The minimum is -1, right?
Mm-hmm.
Maximum is 5. So what's the midpoint?
2.
2 is right. So that's going to be our midpoint. What's the amplitude?
3.
3. So what are they asking us? One of these is the radius. Is our radius 2 or is our radius 3? Radius
It's
is
3.
it's 3, yeah. Radius is 3. And m equals 2 is the boat's height, okay? Or height of the
Mm-hmm.
axle relative to the water. The time to do one revolution is 12 seconds, and the speed of each wheel. What's the formula for speed?
Distance over time.
Right. So what is our distance? What are we looking at when we're looking at our distance? Or you can look at it this way as well. This one is a little bit trickier because you need to find 2 good points, but we can find 2 good points. Let's say from here to here, yeah? What's the distance? How far have you traveled in terms of y? What is this distance? So you're at -1, you went to 5, right? The distance you've traveled is 6
4.
meters. 6, not 4. The distance from here to here.
Oh, okay.
And how long did it take in terms of time? I think each box represents 2, right? 2, 4, 6, 8, 10, 12. 1, 2, 3, 4, 5, 6, 7, 8, 9. Why is it 9? That's the weirdest one. I thought it should be 2. 1, 2, 3, 4, 5, 6, 7, 8, 9. This is the weirdest thing. So each box there represents 24 divided by 9 seconds, okay?
Mm-hmm.
The unit of measurement there, from here to here, it's 24 divided by 9, which is like, what, 2 point something seconds. From here, from our minimum to our maximum, we've traveled 2 boxes, right?
Mm-hmm.
That means the time that has elapsed is 24 over 9 times 2. It's 48 divided by 9 seconds. So that's going to be our time. We have our distance, we have our time. Speed is gonna be distance divided by time. And then you plug that in a calculator. 6 divided by 48 divided by 9. That is gonna be 1.125 meters per second.
Mm-hmm.
And you're done. Black graph is the same thing. I mean, what changes? What's the period of the black graph? This one's slightly trickier. So from here to here we can do, yeah? From there to there? That'll be the
Mhm.
period from here to here, the distance from here to here. So how many boxes have we traveled? 1, 2, 3, 4, 5, 6. 6 boxes. Okay. We know each box represents 48 over 9. So the period
16.
6 times 24 divided by 9. Is that 16? 6 times 24 divided by 9. It is 16, yeah. There we go. The minimum is -1. The maximum is 7. That's the minimum. Your maximum is 7. That means your midpoint is going to be at 3, right? Right here. So that's the height of the axle. So your midpoint is at 3. That's the height of the axle. So your amplitude is going to be 4. Now let's find the speed, which is always kind of tricky because the numbers are not nice here. But let's say I go from here to here, right? What's the height? What's the distance I've traveled? From here to here.
4.
4, so that's my distance. What's the time from here to here? 1 box. It'll be 24 divided by 9. We had that earlier, yeah?
Mm-hmm.
Because there's 9 boxes, 24 seconds, so each box represents 24 divided by 9. So that's 1 box, so this is going to be 24 divided by 9. Therefore, our speed is going to be 1.5 seconds. So the radius, we didn't find the amplitude, did we? Amplitude was 4. So that's the radius. So the radius of the black one is bigger than the radius of the pink one there, the red one. And the bigger boat is traveling faster. Does that make sense? Is it
Mhm.
logical for a big boat to go faster? Yes, it is, right? The bigger it is, the more energy it can generate and the faster it will go. And that is it for this question. Sinusoidal stuff, not that difficult. We're just looking at like maps, graphs. All right, let's call it a day there.
Okay, thank you.
See ya.